Alright, I'm going to begin by reviewing a result of this factor theorem. If a number k is 0 of a polynomial px, then x minus k is a factor of px. On the contrary, if we say that x minus k is a factor of px, then it will show that k is a 0 of px. Now, alright, let's use this result to do part A for us. Okay, here. So all we need to do is, because let it be 0, I mean the point is we want to find the value of this x. So all we need to do is show that p1 is 0. Okay, and you sub x equals 1 into this. And yes, if you do that, you find is 0. So you can conclude that x minus 1 is a factor of px, right? And then this part we have find the polynomial qx such that px is equal to, you know, the product of these two polynomial. I want to write it differently. I'm going to write it like this: x minus 1 equal to qx. In other words, we're saying that when we divide the polynomial px by x minus 1, we get a quotient. And so all I have to do is just divide px, and I'm going to use syntactic division. So I write down coefficient carefully and divide by x minus 1. So we perform syntactic. This would be -3. I get 52, 52, and 0. And so here will be your qx. This is a constant term, and so this is the x power 3. No x squared term, so minus 3x plus 52. And I'm going to write this, state this out. Px is therefore equal to x minus 1. We know what qx is right now, is this x cubed minus 3x plus 52. I think I'm going to refer to this again, so I'm going to call this equation 1. Now, in a complex number, w is a 0 of qx, right? So if w is 0, because it's a complex number, that means the conjugate is 0, 2. Okay, and so sum of roots, which is this, we given the value is 4, and the product of roots, which is this, again the value is given is 13. And so an equation, or rather a quadratic factor, is therefore x squared minus 4x plus 13. Okay, and lastly, the last part we can actually use a calculator to help us, but I'm going to show it algebraically. Now they ask you to find the zeros of the polynomial. We in part A will show that 1 is the 0. We also have this quadratic or rather cubic factor. We can, if we solve it, then you got answer. In fact, we have our quadratic here. In other words, I'm going to start from 1. We have x minus 1 equivalent to x cubed minus 3x plus 52. However, we have shown that we able to construct the quadratic factor as follow. And of course there's another factor linear, quadratic, union, linear. This here is x power 4, so the coefficient is 1, so x cubed, this must be x, the coefficient must be 1, otherwise you will not get x power 4 on the left hand side. And then the constant term is actually -1 times 52, as you can see from here to here, -52. Here you get -1, 13, and so you do not have a choice but that you must take 4, because by only letting this be 4 you get -52, so it's plus 4. Okay, so we have essentially have factorized this px, and so using formula on this quadratic, we get x equals to -b, or rather plus 4, right? B squared, in other words 16 minus 4ac, 4 times 1 times 13 over 2. If you calculate this carefully, you'll find that this is 2 plus minus 3i, and therefore the zeros are 1 from part A, and 4, or rather -4 from this factorized form, and this, right? Isn't it cool? Okay, I hope you do the other questions, and all the best.